Okay, good morning, everybody. Anton, can you hear me?
Yes, I can hear you.
Okay, great. So I hope the rest can also hear me. Welcome to this new PRAESENSA webinar. And the topic today is ANS and AVC. So, presenters for today, Peter Ophe, that's me, application engineer in Eindhoven. And also here is Anton Thiele, also an application engineer in Eindhoven. And yeah, together we will do this presentation. The topics for today, I mentioned that already: ANS, automatic ambient noise sensor, and the AVC function. So the topics: ANS, we talk about the hardware. We will talk about the AVC function, so that is in the configuration page. And also I will try to explain a bit how it works and also what you can expect from ANS and AVC. And also some design requirements. So these are the topics for today. So first of all, why automatic volume control, AVC? Yeah, we will call it during the presentation AVC, but it stands for automatic volume control. Yeah, we all know situations where the ambient noise in an area can change. Yeah, and think about projects, airports, shopping malls, those things. The background noise can change. If you look at an airport, you have an arrival hall that is completely filled, or you have an empty arrival hall. The ambient noise there will change a lot. In a factory, when certain machines are on, off, or off. On a railway platform, many people waiting, talking, or only a few people waiting in the evening. So it's very quiet then. Sports stadiums, where people are quiet, watching, or people are cheering and clapping. Yeah. But that's also a big difference in ambient noise level. So the result of this large variation in ambient noise is that the announcement or receiving the announcement depends on that ambient noise level. Yeah, an announcement can be very clearly audible, yeah, when the noise level is low, but also when the noise level is very high, it is even difficult to understand what the announcement is. So, yeah, that is why we have AVC, automatic volume control, to have a clear and intelligible announcement despite of the background noise level. Yeah, and how do you achieve this? Well, first of all, we have the ANS, and we'll start with the ANS in a moment, and we have the AVC function. So let's talk about the the ANS, PRA-ANS, ambient noise sensor. Looks like this. For those who have worked with AVC in the past and who were used to work with microphones, of course, ANS looks completely different. Yeah. Well, ANS, the ambient noise sensor, it is the noise sensor for AVC, for the automatic volume control. It will monitor the changes in the ambient noise level in a certain area. And then it will send the data of that noise level to the system controller. And it is only data that we send over. So we are using only OCA, yeah, only control data. It is encrypted. And what is important here is that no audio, the audio is transferred via the network. So the network load will be very low. And listening in on the microphone of the ANS, that is not possible because there is no audio from the ANS going to the system controller. Now, and what the system controller then does is that it will adjust the output level of the amplifiers that are assigned to that ANS. Yeah? And we can do that for calls, and we can also do that for music. The noise sensor, we can have 4 noise sensors in one area. Yeah? So we can assign 4 noise sensors to a large area, for instance. Small areas perhaps only need 1, but if it's, let's say, a complete arrival hall in an airport, then you can go up to 4 noise sensors. And AVC will use that data, but it will use the data from the ANS with the highest noise level, which is measuring the highest noise level. Of course, there is a fail-safe operation for this noise sensor. Yeah, if the noise sensor is disconnected, call levels will go to maximum volume, as if there was no AVC at all. Yeah, and BGM volumes will remain at the last setting. So there is a difference between call volume and BGM volume in the behavior of AVC. Yeah. You know, PRAESENSA is EN54 certified. Also, ANS is part of this certificate. So ANS, you can say, is EN5416 certified. Supervision of the sensor. ANS is connected to the network and the system controller is doing the supervision. Of course, all internal processes are supervised in the ANS. And if there is a failure in the disconnect or a disconnection of the ambient noise sensor, then the call level will go to maximum volume and the BGM will stay at the last setting. That was also there in the previous slide. Now the electronics. This is the PCB that is inside the housing of this ANS, and you see it is not just simple a microphone. Yeah, it's a little bit more. There's a complete network circuit for the Ethernet network. There is signal processing. Everything is there, so that is why we need some space on that board. The microphone itself, you see that in that yellow circle. It is a MEMS microphone. Yeah, they call it a MEMS microphone. And you see the dimensions of that microphone, 4x3 by 1.2 millimeters. So it's a very, very small microphone. Yeah, that is actually the size. And you see the components next to it, some resistors and capacitors. You see the size of the microphone. It's really, really small. Basically, it's the same microphone that is also used in your telephone. On the other side of the PCB, you find this little hole, and that is actually the entrance for the sound waves for audio. Then there is digital signal processing. There is a filter over this microphone. Yeah, so that means that we basically cut off a lot of the low frequencies, but also a lot of the frequencies above, let's say 10 kilohertz. You can see that in the graph. You can change these settings if you want. Yeah, but when you do that, make sure that you know what you're doing. Yeah. Now the whole unit is PoE powered, so powered via the Ethernet cable. The different shapes of the ANS. So the mechanics, we have an indoor housing, and that's indoor flush mount, what you see on the left. Then we have the indoor surface mount. Yeah, and then we also have the outdoor housing, and that's an IP65 housing. You see that there is a you can have the version for flush mount or surface mount. You have this back box, and you have a sealed cable entry, a cable gland, 16 millimeters. So you can receive your cables over there. Yeah. What you also can do is suspend the ANS via the cable. Yeah, there is an option for a safety cord. That's also there. And then you have a pendant ANS. So you can suspend it from the ceiling and then a few meters down if you want. There is it, safety cord I is there. And the front can be black or white. You will receive two fronts when you order an ANS, and that is a white front and a black front. And you can select one of the two. If you want to have a different color, you have to paint it, and that's also no option. About the size of the ANS, you see the size is about 13 centimeters. Yeah, so it's not a very small thing. It's much larger than a microphone. Yeah, then if you take off the cover, so that is the cover on the front, you will find the microphone. You see here, this is when you take off the cover on the left side, and on the right side you see where the microphone is. If you take out that little protection cover, you will see that there is that little hole of the microphone. Yeah? And you also have there two LEDs on the front, yeah, yellow and green. The yellow one is for the fault indication, and the green one is the power indication. The green one during normal operation is always on. And also this ambient noise sensor has a identification mode, and in that case both LEDs will start blinking. There's also that reset button. You know that all PRAESENSA devices have a reset button to go back to factory defaults. And you also have that for this ANS. There is a reset button, and then everything in the ANS will be deleted. And especially the security key for Omnio will be deleted, and then you can connect it to a system. You see the microphone here. I zoomed in a bit on the front now. You see the microphone entrance, but on top of that, you also see that air vent, and that is to for the back box that it will equalize the pressure inside and outside the box. Yeah, so that there is an air vent. Be careful, don't close that. Make sure that it is always open. And then the rear panel, you have the RJ45 with that is the network port, and you have the two LEDs that come with the RJ45 socket. So that is the network port. There's only one port. Yeah, so it will only receive one network cable, one PoE. Yeah, and then the block diagram, you see that we have the microphone there, then we have audio processing, we have a controller, and we have the switch. There is a switch inside, even when it has only one port, there is a switch inside. It's 1 gigabit wired port, RJ45 and PoE powered. You've seen that before. Control protocol OCA, and data security is TLS. And here you see the different symbols with their explanation. Okay, that was the ANS, the ambient noise sensor. This ambient noise sensor is used for AVC, automatic volume control. Yeah. Oh, now we talk about AVC and ambient noise sensor. Now, AVC is the algorithm in the system controller, and it is the algorithm that can change the volume in the amplifier channels. Yeah? AVC will respond to the changes in the ambient noise level in a certain area. Yeah? So it is ANS that measures, sends the data to the controller, and then the AVC algorithm in the controller will take care of the volume of the amplifiers. Yeah? And that means noise level goes up, volume goes up, and we do that to have maximum intelligibility for an announcement. Yeah. And the other way around, when the noise level goes down, the volume of the volume goes down. And actually we do that because if the volume goes down, the noise level goes down, we don't want to have those very loud announcements, yeah, which can be quite annoying. Yeah, so we go down with our call level to have a more comfortable level of the announcement. Now, one thing is important with AVC, that AVC only works for normal business priority calls, so not for emergency priority calls, and that means priorities up above 223. So 224 and higher are emergency priorities, and so AVC doesn't work for those calls. They will always be at maximum volume. Now, something about AVC, some misconceptions. Yeah, And what is wrong? Well, it is not completely wrong, of course. AVC increases the volume when the ambient noise level goes up. That is true, of course, but there is a limit. There is a limit to the volume that the call level will go up. Yeah, there is a maximum to the volume of the speakers, the volume that the speakers can deliver. So what is right is actually the other way around. AVC reduces the volume when the ambient noise level goes down. Yeah. So we have a maximum volume for the call, for the announcement, and we reduce that maximum call level when the ambient noise level goes down. I mentioned there is a limit to what AVC can do. Yeah, and the limit is basically the maximum volume that the sound system, the PA system, can deliver. Yeah. So the design of the PA system has to be that it can handle those a certain background noise level. Yeah. So if the noise level gets too loud, question is, do you want to go with your call level over that noise level? We'll come to that later. Yeah, AVC reduces the call or the music level when the ambient noise level goes down. That is how it works. What is a limitation of AVC? Yeah, well, you have noise, people talking, a lot of people talking, yeah, and you have background music. The ANS doesn't know the difference. For ANS, for the noise sensor, background music, for instance, is measured in the same way as the ambient noise. So when you play background music, you have to be careful. Yeah, it has to be at a low level. Yeah, and that's why it's called BGM, background music. Yeah, and another limitation, and that's not really a limitation of AVC, but AVC is not a magical tool. Yeah, it will not solve acoustical problems. When you have an area with a very high reverberation time, that is something AVC cannot change. That is an acoustical property of an area, of a room, and AVC cannot do nothing about that. Yeah, so that will not change. We will change the volume of calls, announcements, or background music. So let's connect the ANS to the PRAESENSA system. It's PoE powered, we know that already, and it has an Ethernet connection. And basically, it can be connected anywhere in the PRAESENSA system. It doesn't matter where it is connected to the network, but you need power over Ethernet. Now, the simplest way to connect it is to connect it to an MPS, MPS3 in this case, where we have a free network port with PoE, and then you can connect your ANS there. Another option is that you use a PoE insert. Then you can connect the ANS to any port in the network. Yeah, and if you really need more PoE ports, what you also can do is use the switch. Yeah, the switch that is in the program of PRAESENSA, the 8-port switch, and each port has power over Ethernet. And so you could connect there 8 ANS to one of those switches. Yes, you have different options. Now, I mentioned already, ANS does not affect emergency priority calls. Yeah, calls priority level above 223. That basically means that the PoE for those ANS circuits, for those ANS sensors, do not have to be redundant. Yeah, if the power supply fails, you will get a fault. Yeah, unit missing. Yeah, but the system itself is not affected. Operating modes for the AVC. We have 2 operating modes. Sample and hold is the first one. We use this for business calls. Yeah, business calls, and that means a call with live speech or with a pre-recorded message. Yeah, and here we measure the ambient noise, and that is the sample phase. Then in the background, the call level is adapted to that to the actual noise level. And then when the call starts, the call level is fixed, so there will be no changes anymore in the call level. And that is the hold phase. So we have sample and hold. We sample first, and at the moment the call starts, we hold and we freeze basically the call level. If during this call the noise level changes, the call level will not change. Yeah, we don't want that a higher background noise level will increase the other way around. We don't want that the call itself will affect the measurement. Yeah, calls are loud, can be loud, of course. Yeah, and we don't want the call to affect the AVC function. And again, if the connector is the ambient noise sensor is disconnected or has a failure, the call level will go to maximum volume. Now, a lot of text, but perhaps this is more clear. Here we have two graphs. One is the noise level and one stands for the call level. So here is my noise level, and the noise level is going up. It can be fast going up, it can be slowly going up, but AVC will respond to that, and the call level will respond to that as well. So what will happen is the moment the noise level goes up, also the call level goes up. Yeah, and you see it's not a immediate change, it is a gradual change. Yeah, and then if there is a call, yeah, you see that the call level is frozen. But you also see that when the noise level stops and goes down again, the call level stays the same. And after the call, when the call is finished, then the call level will go down again. But if the noise level is already very low, the call level will stay very low. Yeah, and you will hear the call in a very at a very pleasant level. So this is a bit how AVC works for a call. Yeah, you see, so we have a sample part, we have the hold part, again we have a sample part, and we have a hold part for the next. So that is the sample and hold function. You see all kind of we have all kind of settings for this AVC. So first of all, that is the ambient noise threshold. Yeah, that is the ambient noise level where AVC should start working, and you can set that in the configuration page between 50 and 90 dB SPL. Then we have the attenuation range. Yeah, how much can AVC change the volume? Then the attenuation slope. Yeah, how much does AVC change the call level in relation to the noise level? Yeah, so 1 dB up means 1 dB up means 1 dB change in call level, but it can also be at a lower level. So 1 dB noise level up means 0.75 dB call level going up. And then the last part is the adaptation speed. How fast are we doing this? How fast will we respond to changes in the noise level? Yeah, and most of the time you want to have it slow or medium. You don't want AVC to respond very quickly to noise changes. Yeah, there can be a truck passing by. That's only a few seconds. You don't want AVC to respond to that short, let's say, burst of sound. So these are the settings that you can do in the configuration. So this was sample and hold. We go to the tracking mode, and tracking mode is what we use for BGM, background music. It is measured, ambient noise is measured constantly. That's still the sampling phase. BGM level is changed, yeah, to the actual noise level. Yeah, a call will always overrule BGM, so no question there. Yeah. And what is important, because the noise level is always measured all the time, and that means also that it will measure the music signal, that the noise sensor should not be too close to the source, to the speaker. Yeah, because it will measure the music as well then. Yeah, so far away from the speaker, if possible, and more close to the noise source itself. So the people walking. So yeah, and in case of a disconnection or failure of the ambient noise sensor, BGM volume will remain at the last setting. It will not change anymore. Also here, a graph. Yeah, you see here the music is always playing. The noise level goes up, and the BGM volume will follow. But you see, not very fast. It's going up very slowly. And later, when the noise level goes down, BGM level will also go down. But you see, it's not an immediate response. It will be quite slow. Yeah, so we have a sample. The sample phase is always there. And the settings here are the same as for the call. Yeah, so basically AVC is made for calls, but you can also use it for background music. But it are the same settings that you use for the call, for the announcements. Let's have a look at the configuration. How do we configure this? Yeah. Well, first of all, and you do that with every component in the PRAESENSA system, you have to add the ambient noise sensor to the configuration. And that starts on the system composition page. So now we have the option PRA-ANS as a new device. Yeah, add the ANS to the system composition page. Yeah, you can give it a name. You have to select, of course, the host name. That is the host name of that ANS. And then you can also, for instance, add the location where the device is mounted, in which floor, which area. And the next step is go to zone options. And this page you know already, for those who have been working with PRAESENSA. There is added the ANS, the noise sensors. Yeah. So first of all, you select the zone. Then you can assign the noise sensors to a certain zone. Yeah. The maximum is 4 there. In this example, you see 2 noise sensors for zone 1. Yeah, and then what is important here is the ANS cannot be assigned to a zone group. So you always have to assign to zones. You have to assign it to zones. Then you go to the volume settings. That is a bit lower in the screen, where you enable AVC, and then you select the different controls, and that is one control for BGM. You can also select control for business calls. You can select one of them or both. Yeah. And then we come to the AVC settings. How does the AVC respond to the ambient noise? Yeah, first of all, the threshold. That is the level where AVC starts attenuating the audio. Yeah, so not increasing, attenuating. Yeah. So this is the ambient noise level where the amplifiers still have maximum volume. Yeah, so at 70 dB SPL, what is now in this example, the amplifiers will have maximum volume. The next step is that you go to the attenuation range. You can have 4 dB and then up to 18 dB. As a rule of thumb, 10 dB, around 10 dB, that is a good setting always. Then we have adaptation slope. Yeah. How does AVC respond to the changes in the ambient noise? Is it a one-to-one relation between the two? Or if it is also possible that the volume goes up a little bit less than the rise of the background noise. And then the adaptation speed, that is how fast AVC will respond. Yeah. And here you can select 0.2, 0.5, and 1 dB per second. If you're testing AVC, it is always nice to use the fast setting, because then you have a quick response of AVC, and but you should not forget to set it lower when you're done with testing. Yeah, this is a screen for audio processing. And you see this is more or less an A curve, A filter, what you see here. But you can change it. If you say, I want to have it narrower, yeah, I can imagine that you want that, then you can change this EQ setting. But you have to know what you're doing. That's important. You can always go with that button A weighting. You can always go back to the A filter. Yeah, and when everything is set, then you can go and you can test AVC. Yeah, and we can do that now in the diagnose page. Yeah, so you select there in the diagnose page ambient noise sensor, and in this case you see only one. Yeah, you open the required sensor and start the measurement, and what you will see then is the SPL, the sensor level, is displayed here, and that's a real-time value. So when the noise changes in an area, you will see immediately that this also will change. Now, remember what the settings were for this zone. This is zone number 1. Yeah, we selected there. The threshold is 72 dB SPL, and we have an attenuation range of 15 dB. Now we measure now 61 dB SPL. There is no offset, no correction there. We'll do that in a moment. But you see 61 dB SPL, that is about 10 dB below the 72. It's 11 dB. And you see that the attenuation here is also 10 dB. You see already the response of AVC. The noise level is 10 dB below the threshold, and immediately the volume will go down 10 dB. So AVC is working already. Now, how do you do the settings of the AVC now? Well, first of all, you need an SPL meter, sound pressure level meter. And we have a Neutrik here, NTI. And I did the measurement here. Ambient noise was 69 dB SPL. And the volume here on the right side where it says noise level should be the same as what you see on your SPL meter. And that is why we have this offset. It's quite possible that the noise sensor, the ANS, is 5 or 10 meters away from where you are measuring. Yeah, so you can adjust the measurement from the ANS to the measurement on your SPL meter. So what we do, we just add here 9 dB offset. And you see now the reading of the noise level from the ANS is the same as on the SPL meter. And when that happens, you see automatically what the response is of the AVC. The threshold setting was 72. We have now a measurement of 69, and the AVC level will go down 2 dB. Yeah. So already it is going down. It's not at full power because the noise level is not at the threshold. There's still a difference. Yeah, and the moment that the noise level is going down a lot, so this is very quiet, 43 dB. Yeah, you will see in the in this page where we measure 43, you see that 9 dB is still there, but the 43 is matching the value that we measure with the SPL meter, but that is something like 30 dB below the threshold, and you see the range was 15 dB. So what we see now is that the volume control for the zone is now at -15, and that is the lowest value that we set for the for the settings of AVC. AVC range was 15 dB. And so this is the page where you do the settings for the and the adjustments for AVC. Now, what can you expect from AVC? Well, if you have no AVC, it will behave like this. Yeah, you have a call level, a fixed call level, let's say 85 dB. And then you have a noise level, ambient noise level. And that can be very low, but it can also go up. Yeah, and it can go up more. It can even be higher than the call level. Now, and you see probably already what this means. When you have a very low noise level, the call will be quite loud. Yeah, when the noise level go up, but still is below the call level, then we have here a range, a difference of 10 dB. And there is a rule of thumb that says that a call level, when the call level is higher than 10 dB above the noise level, that the call will be audible and clearly intelligible. But when the noise level goes up more, you see that at a certain moment it's only 5 dB. And at a certain moment, it is even much louder than the call level. And then it will be difficult or almost impossible to understand what the message was, what the announcement was. Yeah. So here we have well, it is a large variation, of course, in noise levels, 30 dB. Now, what would an ideal AVC do? Well, there is a noise level, and the AVC would like to follow. That would be great if we could do it like this. Yeah, everywhere we have that 10 dB signal to noise. Yeah, and then that would be great. If you have this large range of noise level change and with a AVC range of 30 dB. Yeah. But this is not really practical to have an AVC range of 30 dB. It's really a lot. It's a lot, but it's also not very practical. So what do we have with PRAESENSA? Yeah, we can do this. We can have a difference, a call level above 10 dB above the noise level. It depends, of course, on the design of your system. Yeah, that would be great. Yeah, but there are limits here. Our AVC range, if you look at the specification, is 18 dB max. Yeah, so a noise level change of 18 dB we can follow. In this example, you see that the noise level difference is 15 dB. That should be no problem. We go back to our large variations in ambient noise. Yeah, and you see, if you have a very high ambient noise level, you have to be sure that your sound system, the PA system, the speakers, can deliver more than the highest noise level. And in this case, we have a noise level of 95 dB. Yeah. So the system has to be able to produce 105 dB. Yeah. So this is okay, but here it is already a bit difficult. Yeah. So it could be that your call level is not high enough. Yeah, that the speakers cannot handle the highest call level or the noise level. And what happens then is that if we have a range of 18 dB, that for the high noise levels, yeah, we cannot just get a higher call level. Yeah, and that would mean that when there is a lot of noise in an area, we cannot cover that with a sound system. Yeah. Now the solution for that is, yeah, of course, have a bigger loudspeaker there, a higher sound pressure level from the loudspeaker. Another option is, of course, wait with the call until the noise level is lower. You can imagine in a football stadium, there is of course a lot of noise, but when they score the goal, the noise level will go up dramatically. It is very difficult to go over that noise level. So if you wait for 5 or 10 seconds with the call, yeah, the crowd is the noise level is lower again, and then you can make your call. That is an option. Yeah. Sometimes a new speaker design with a higher sound pressure level is just too expensive. Another option is when the speaker design is right, yeah, so we can handle the high sound pressure levels from the background noise, yeah, but we still have that AVC range of 18 dB. And you see what happens then is that we can follow the noise level when it is very loud, but with a range of 18 dB, we cannot follow the noise level when the difference between the noise and the call is, when the noise level goes too far down. And that means that at a low level, we will still have a kind of a 20 dB signal to noise. And that is a quite loud call. So that is also something to take into consideration there. Yeah. So in this case, we can handle the high noise levels, but the call will be a bit loud when the noise level goes down. These are all things that you have to take in consideration. Some design requirements. Yeah. Now, we talked about ambient noise levels already. You have to determine what is the maximum expected ambient noise level. Yeah. And the easiest way to do that is just take your SPL meter and walk around, and then especially walk around when it is very crowded in an area. So in an arrival hall of an airport, you go there and you measure when people are getting out of the airplane and walking through the arrival hall. So by measurement. But there are also tables. You can find them on the internet where you have certain noise levels in certain environments. These are standard tables. You can find them on the internet. That should be no problem. And then you have to decide about your call level. Should your call level be higher than the highest noise level? Or will you just accept that you cannot have a higher call level when the noise level is very high? Yeah, this will have a large effect on your system design. Yeah, the number of speakers, number of amplifiers. Yeah, if it is very loud and the background noise is very high, sometimes better to have ear protection, hearing protection. Important is that the system design, the speaker design, should be able to handle the necessary requirements for power and SPL, sound pressure level. That is important. Your system design has to be right. Then something about the location of the ANS, the sensor itself. Yeah, the ANS should be in the reverberated field, and that means not too close to the noise source. Yeah, not too close to the noise source, because then you are in the direct field. So there should be a certain distance between the noise source and the ANS. And it also depends on the room acoustics. Yeah? So be careful where you suspend or mount your ANS, your noise sensor. Try to keep it away as much as possible from loudspeakers, especially if you're using background music. Yeah, music will be measured as noise. Another thing to keep in mind is that don't mount the ANS too close to an airflow. Yeah, airflow of an air conditioning or an air treatment system. Yeah, where air is blowing out of the ceiling. Yeah, if it is blowing direct into the ANS, the noise sensor, that will create a false measurement. Yeah, you will not measure then the ambient noise in that area. Yeah. Also, not too close to large machines. Yeah. Though large machines may produce a higher noise level than in the rest of the room. Okay. That is all I wanted to tell you about ANS and AVC. Thank you for being in this webinar. Thank you for your attention. If you have questions about projects and AVC, also contact your local Bosch office. Yeah, and then probably if they don't have the answer, as I mentioned, they will come to us. Yeah. For the rest, thank you for attending this webinar, and see you next time, perhaps.
Thanks.